In this example, we'll solve the system of differential equations x prime equals negative 3x plus 6y and y prime equals x plus 2y by changing it into a second-order differential equation with constant coefficients. Taking the derivative of both sides of the second equation gives y double prime equals x prime plus 2y prime. And replacing x prime in this equation with x prime equals negative 3x plus 6y from the first equation gives that y double prime equals negative 3x plus 6y plus 2y prime. To get this equation completely in terms of y and its derivatives, we can use that x equals y prime minus 2y from the second equation in the system. And now replacing x with that, we have negative 3 times y prime minus 2y plus 6y plus 2y prime. And distributing negative 3 gives negative 3y prime plus 6y plus 6y plus 2y prime. In consolidating terms, this yields negative y prime plus 12y. Writing this differential equation y double prime equals negative y prime plus 12y in our standard form for second-order differential equations yields y double prime plus y prime minus 12y equals 0. This is a second-order differential equation whose characteristic equation has distinct real roots. We solved this before to find the solution y equals c1 e to the negative 4t plus c2 e to the 3t. Now to find x, we'll use that x equals y prime minus 2y. And to do this, we'll need to compute y prime, which is negative 4c1 e to the negative 4t plus 3c2 e to the 3t. Now using the equation x equals y prime minus 2y with the y prime and y that we just found, we get that x equals negative 4c1 e to the negative 4t plus 3c2 e to the 3t as y prime minus 2 times y, which is c1 e to the negative 4t plus c2 e to the 3t. Distributing the negative 2 and combining like terms yields negative 6c1 e to the negative 4t plus c2 e to the 3t. So we now know functions for the solutions of x and y. So we have a solution to our system. I would like to note, though, that since c1 and c2 are defined as constants in the solution for y of t, we do not want to replace negative 6c1 in the equation for x of t with some other constant, because if we did this, we would lose this relationship between the constant coefficients in y of t and the constant coefficients in x of t. Namely, that the coefficient of e to the negative 4t in x of t is negative 6 times the coefficient of e to the negative 4t in y of t. So we will leave both functions x and y in terms of the same two constants c1 and c2 instead of introducing any new ones.